This is a brief introduction to databases, database management systems, and the SQL programming language, and we'll relate that to LibreBase program that we're using for this training. So briefly, the anatomy of a database. What exactly is a database and what is it made of? A database is a group of interrelated tables, and tables contain information about attributes of objects. Attributes can reference records in other tables, and you can use a database management system to quickly retrieve information from these tables. Fields. Fields are common to both files and databases. Fields are the smallest unit of meaningful data that can be stored in a database. Okay, there are four main types of fields: primary keys, secondary keys, foreign keys, and descriptive fields. So a primary key is a field whose values are unique to each record, and I'll talk more about that later. A secondary key is an alternate identifier for a database. Foreign keys are fields that point to records of a different file in a database. And descriptive fields, which is basically anything else, any other fields that store data. Records. Fields are organized into records. Like fields, records are common to both files and databases. Records are collections of fields arranged in a predefined format, so they would be each row in a table. Records can be defined as either fixed lengths, so every instance has the same size, or they can be variable in length. This is just a visual representation of what I was just talking about. So here we have a simple table, has 5 columns and 3 rows, and the columns represent attributes, or the columns are fields. So each of the columns is a unique piece of information about each record, or not necessarily unique, but they're a piece of information about each of the rows. And then the rows are individual units. So Alexander Dumas, his date of birth, his country of birth, and his date of death. So those are all one record. A primary key is an attribute in a table that identifies each row uniquely. So I have here as an example, in a customer table, name could be a repeating value. You could have multiple people with the same name, same last name. If you used a phone number, well, it could be that phone number could be used by multiple people, and the phone number could potentially change. So what makes a good primary key is a unique combination of letters and numbers that you would never find anywhere else, like a SIN or a student ID number. These are things that that are designed to be different for everybody. So, and another thing is they should have no null values. That probably goes without saying. And sometimes a database designer may use an auto number to give unique serialized numbers as the primary key. So every time a new record is added, a new primary key is automatically generated. This is just a representation of primary keys. So we have 2 tables here. The first one, the red colored one, and then the second one, which is the blue colored one. So they both have a primary key, student ID and provider ID. And then you can see there's a third table below that has both student ID and provider ID. So in that case, the primary keys, student ID and provider ID, are foreign keys to this other table. So this is a linkage between the different tables. Here are a few pointers for good database design. So when you're designing your database, you should develop a logical design. So you should really sketch it out beforehand. You should figure out which entities are involved. So I have here as an example, customers, orders, and products. Those might be 3 things that you would find in your database. And convert those into tables with attributes. Each table should cover one topic and one topic only. And this is something I'll talk about in a little bit. For example, if you have a database about authors and books, attributes related to books and attributes relating to authors should be stored in their own separate tables. And then you have a relationship between those tables. And you should remove repeating information. Determine relationships and cardinality. So that's another thing I'll talk about. Is there a one-to-one relationship? Exactly one-to-many or many-to-one relationship? And think about naming conventions. Generally, for field names, you don't use spaces or special characters other than underscores and no capital letters. So name your tables well. Something to note well in your database is your data types. So I have listed here the most common ones. So you can have an integer, which is just a whole number, numeric, a decimal number or float number, char or car, which is a text of a fixed length, so it can't be longer than a certain number of characters, and varchar, which is however many you want it to be, and then date. Date format is supported by databases, so date, month, year. A relationship in a database is an association between entities. So this can be mandatory or it can be optional. So a relationship is as simple as a real-world association between two different things that are contained in a database. So a customer places an order. There's a relationship between a customer and the order they place, and the reverse order is placed by a customer, or employee works on a project. Cardinality. So cardinality is a way of expressing the different types of relationships that you can have in a database. So there are three different types of cardinality. You can have one-to-one, one-to-many, and many-to-many. So one-to-one means that each record in one table can be related to records in another table, and there is only a singular relationship between those tables as far as those records are concerned. So there are three examples here. Each department has a manager. Each department has one and only one manager, and each manager manages one and only one department. So there's a linkage between department and manager, and there's only one of each related with the other one of each from the other table. Then you have one-to-many. So a customer places an order, but a customer can place multiple orders, but the order is always placed by one customer alone. So it's only the many is in one direction. One customer can place many orders, but one order is placed by one customer. So that's why it's not many-to-many. Whereas in the third example, we have instructor teaches a course. Each instructor teaches one or more courses, and each course could be taught by multiple instructors. Not usually, but in that case, many instructors can be related to many courses. There is no limit to the number of courses an instructor can have, no limit to the number of instructors a course can have. Whereas with the orders, there is a limit to the number of customers that an order can be affiliated with, but no limit to the number of orders a customer can be affiliated with. So those are the three different types of cardinality. This is just a visualization of cardinality, so you can see the different types of relationships. A UML diagram, or United Modeling Language diagram, is a standardized way to signify components of a database and their relationship. So this image is basically what I was just talking about before. You have authors and all the fields in the author table, and then you have titles and all the fields in the title table, and you also notice there's an ID number in both of them, so that would be the primary key. And then titles also has a foreign key, which is the primary key of the author table. And then you can also see that the relationship between those two tables is mapped. So we have 1 to n and 1 to 1. So one author can have n, any number of titles associated with them, whereas one title can only be associated with one author. In most cases, I suppose you could have multiple authors, but for the purposes of this illustration, one book title has one author associated with it, while an author can have more than one title. Data integrity. There are three types of data integrity designed into a database, or that should be designed into a database. Key integrity. Every table should have a primary key. Domain integrity. No field should have a value that lies outside the range of legal values for that field. And referential integrity. So all foreign key values match primary key values in related tables. There's no discrepancy between the different keys. Classes. Classes are a grouping of objects that have the same properties. So in database design, you use many tables that are related somehow or another, and each table covers a particular topic or a theme. And so you call this theme, this topic that is covered by a table, a class. So a class is a collection of objects with the same attributes, all of which will be found in a table. So it's just another term that we use, really. A class is a logical, abstract relationship, while a table is a physical expression of that class through the database software that you're using. And a method is a function that does a calculation, that can do a calculation on that table or that class. So below illustrated here you have each of these tables with, class, and then the different attributes of those classes, and then below that you have the methods, which are optional. You may not have any methods for a particular class. The concept of normal form, I'll just quickly introduce normalization and the three different levels of normalization. Normalization is a technique to reduce redundancy and undesirable characteristics in a relational database. So it's a process that we can use to improve upon our databases, database design. So in doing normalization, you can simplify your queries and you can avoid maintenance problems when updating. So there may be no proper place to insert data if your database is not in normal form. And it is a three-step technique, so I will introduce each of those three steps. First normal form, that's the first degree in normalization. So for a table to be in first normal form, each attribute cannot be further subdivided. So for example, if you have a full name as one of your fields, well, you can break down full name even further into first name and last name. So it's not in first normal form if it can be broken down. Each cell, as a result of that, each cell would contain only one value, and there are no repeating groups. So each row has a unique value. There are no duplicates, and also, it's not on here, there would be no null values if a table is in first normal form. So it may be a little easier to understand if it's illustrated graphically. So this table here, you can see there's a colors column, and colors has multiple values: red, blue, red, yellow, red, blue. So for this table to be in first normal form, all of those colors should be broken down into one single color per item. So you see t-shirt red, t-shirt blue in the second table, whereas in the first table is t-shirt red, blue. Next is second normal form. For a table to be in second normal form, first of all, it needs to be in first normal form, but to be in second normal form, all fields can only be identified by the primary key. No partial dependency where fields are dependent on part of the primary key. So what that means visualized is that the price and tax columns are dependent on item, but they're not dependent on color. And the item and the color together, those make up the unique identifier of this particular table. There's not really a true primary key here, so we have two identifying columns, item and color. So if you look below, now it's broken down more. So since price and tax depend on item but not on color, there's a separate table that's showing that dependency of price and tax on item, and item and color as their own table. So now third normal form, once a table is in first and second normal form, to be in third normal form, no information in the table depends on anything other than the primary key of that table. So that means no transitive dependencies, which is different than partial dependencies. So, for example, if we had a customer table, the age may depend on the date of birth, but the date of birth depends on the name of the person. For it to be in third normal form, everything needs to depend on one key, the primary key. So in this example, you can see that we have the table with item, price, and tax, but tax doesn't directly depend on item. It depends on price, and price depends on item. So for this to be truly in third normal form, you would have to break that down. So we have it broken down so that in the three tables below, so that everything depends on something else, the primary key. So price depends on item, that's one table, and tax depends on price, so that's another table. Data modeling, an important step in designing databases is to logically model the relationship between tables. So what is the most intuitive way to link tables together? And this is really useful when you're actually trying to create a query, if you can see a logical way that these tables relate to each other. Using UML diagrams to create a conceptual design, which we have here, breaking down data into as many separate classes as possible to form the relationships. So all these different relationships, all these different cardinalities between all these other tables, it's a lot easier to think about these things logically if you sketch them out like this. Many small tables are better than one large table. So sort of like a third normal form, right? Break down things into as many different things as you can break them down into. Forms. Forms allow you to enter data to populate your tables. With LibreBase, and I'll show you this, you can build them using the form wizard. You can include radio buttons and drop-down menus, and you can also create forms with programming. So what this is, it's basically, it presents all the different fields, and it allows you to enter whenever you have a new record to enter in a field. It presents all of the different things that you would enter into that record in one place. So the example below here, we have first name, last name, gender, and date of birth. So for whatever table we're making this form for, you have a first name field, a last name field, a gender field, and a date of birth field. So you can just, it's just an easy way to enter in record information at one time. Again, I will show briefly how you would do this. And if you would use radio buttons, if there's, say, a limited number of options, so there are only 2 options for gender, for example, and you would set all of these to have whatever type of data goes into that particular field. Reports. For data output in LibreBase, you can create reports. Reports are similar to forms, but the focus is more on retrieving the data rather than inputting the data. So it's creating a final result of the data you have and displaying it. Structured Query Language, or SQL, is a programming language that is used to talk to databases. So the user specifies certain conditions with a query, and the program will go through all the records in the database and select those that satisfy the condition, and the results of that query will be displayed as a table. So if the words select, from, and where, those keywords show up, that's a pretty good sign that you have a SQL statement, because those are pretty common across SQL. Here are just some of the things you can do with SQL statements. So you can manipulate your data, like inserting values or deleting values from your table, and you can define data. So you can create your database, drop your database, or create and drop your tables. And of course, you always can select things from your tables. This is an example of a select statement in SQL. So the general syntax is select a column from a table where a certain condition is met. Select from and where, those are the keywords that you would use for the select statement. So below this there are a couple of examples for how that would work. So select star from course. Star, that's just means select everything. So all the columns from course, and course is the name of a table. And then the example below, it says select description from course. So select the description field from the course table where the title is like using. So title, that's another, that would be another field. Like, it's basically the same thing as equals, but in this case we have using percent sign. And the percent sign means that the characters USING can be followed by any number or no number of characters after those first 5 characters. It doesn't matter what they are, as long as it contains those first 5 characters, then it will be selected. So using computers, using math, using literature, those would all be selected from this selection. It would select the description and the course from the table if the title starts with using. This is an example of how you would insert values into a table with SQL. So the syntax would be insert into a table, and you give in parentheses the names of the columns, column 1, column 2, column 3, and then values, whatever it is, text 1, text 2, num1, so depending on the data type. So for the first 2 columns, it appears we have text columns, and the third one is a numeric column. This is how you would delete. The syntax is delete from table where a certain condition is met. So the example, delete from the employee table where the last name column is equal to Jones. So everybody who has the last name Jones gets deleted from the table. Something to note well is that if you delete something with SQL, or really with any form of programming, any programming language, then it is gone. There is no way you can get it back. There is no equivalent of a recycle bin. So use delete very carefully. Only delete something if you are absolutely sure you would never want it back. This is the last example I'll give, a little more complicated, selecting from multiple tables. So if you have 2 tables in the same database, this is how you would select from them. So supposing they have a relationship. So there's a primary key and a foreign key between those 2 tables. So in the select statement, you select table 1 dot column 1, so a column from table 1, table 2 dot column 2, so a column from table 2 where a certain condition is met. So the example here is select course.title, course.description, and teacher.name. So that means select the title field, the description field from course, and the name field from teacher. And selecting those from the 2 tables, course and teacher, where course.teacherID equals teacher.teacherID. So both of those 2 tables, course and teacher, have a teacher ID table. So where one equals the other, then make a selection of the title and the description and the teacher name. And then the last thing here is order by. So it just orders them alphabetically by teacher name and then by course title. So if, say, one teacher teaches 3 courses, then when this is listed in a query result, it will arrange the 3 courses taught by that teacher alphabetically by the title of the course, since the title of the teacher's name is going to be the same in all 3 cases.
When you open up LibreOffice Base, it will take you directly to this wizard where you can either create tables or you can import ones. So if I want to create a database, I can do that. This is what's selected here. And it creates an HSQL, HyperSQL database, which is the default data type. I can open an already existing file that I've created, or I could connect to an existing database, and that includes more than just a database. It could also be a spreadsheet that I have in a few different formats, and Microsoft Access it supports as well. So if I were to pick spreadsheet, I could actually, if I go to my desktop where I have this, continue. I've set to register the database here, but you don't have to. And it sets to save as an ODB file, which is an open database file. And you can see now that it's open, I have that table that I just imported, and you can see that it's here. And I have another database here, and I can go and create a table. So I could use the wizard to create a table, and here I have the option to set any number of fields I want. So it gives you a large sample that you can pick from. So I could mix and match all of the selected things from all of these different different samples. So maybe city, and there are personal ones too. So like that, say last name, first name. And then you can set the different types of data. So it already populates it with suggestions. So category ID, it says it's an integer, but you could change it to anything here. Category ID is integer is probably a good one for that, since it's an ID. Auto value, you can set it to automatically enter a new value every time you add a new record. So maybe I'll do that. And again, it populates it with the logical thing for each of these other categories. So category name, probably text, city, text, text, text. And you can also set the requirement if it needs to be entered or not. And so primary key, I can create a new primary key, which I can also set to auto value. Or I could use one that I already have. Maybe category ID is a good one. I can name it. And then create. And so I have my table here is empty, but I could start to fill things in. So category 1. And so on. I have this existing database that I've opened up and has a number of tables already in it. So for example, this is the doctor table. So a couple things I could do is I can go and make a query with the tables I have. So I could make it with SQL like that. Maybe I'll open up one of my tables just so I can see how to select from it. So I could just create a select statement in here. So select from the name of the table and the condition. Then to run it, I press that. And see, it's selected that and that from this table where the gender equals 2. So I'll close that, and you can save the results of the query as its own table, but I won't. I I could also use the wizard to create a table, the wizard to create a query, which might be better because if you do it in the SQL view, you can always make a mistake. You could leave out a comma or something, so this just fills it in automatically. So if I go to my doctor, and they'll say I want all of my fields available, and I can skip this, and this is my selection. So I can make the same query that I made before by just filling in fields. Gender is equal to 2. And then just leaving these as default. And then it selected everything, this time everything where the gender is equal to 2. So I can make a form, and I could also go into the wizard to create the form. So I will select my table. I'll go back to the doctor. Maybe I'll just add in first name and surname into the form, and there are a few more settings that I won't worry about. Maybe you can change the design around like this if you want. And you can change a few other things, like whether this form allows you to add new data, and color, the name, and now it's created. So, and what you can do is sort through all of the records with the form. So it's a nice way to show all of the information at once, especially if there are a lot of fields. So I can just go like this through all of them. If I want to create a new one, I go to the last record, then press next, and then fill in my own record like that. So in that last form, I neglected to include this field, which is a required field, so it wouldn't let me enter the new record I just created. So now I've created a new record, so that was the primary key. So now if I go back to that table, the new value that I entered is there. I can also do a report, which is done in much the same way as a form. So I can go into this wizard, I'll go back to my doctor table, maybe I'll just select these 4 fields and add them, change the labels if I want, I'll just leave them as they are. I won't worry about grouping for now, and sorting. It's just set to sort them alphabetical, and then I can define how I want it to look, so maybe just one column. And then dynamic report versus static. Dynamic means it'll change every time the table is updated. So static, it won't. It'll just create a snapshot of what it looks like right now. So I guess I'll set it to dynamic. And here's the report that I have with all the fields that I wanted included.